Hidden deep in Canada's far north lies a fault line scientists once believed was dead. Now new evidence reveals it's alive, silently storing energy that could unleash one of the largest earthquakes in North America's history. The question is not if it will break, but when. Welcome back to MeteoFoco, where we shine a light on the planet's most intense forces. Our focus today takes us to the most extreme northwest of Canada, a place where the boreal forests stretch out to the horizon in an unbroken sea of green, and the dominant sound is the profound, almost overwhelming silence of nature. Yet beneath this tranquil, ancient landscape lies a geological secret, a colossal, hidden force that is fundamentally about to change everything we currently understand about seismic safety across North America. We are specifically talking about the Yukon Territory, a remote expanse of wild, breathtaking beauty and profound isolation. Here, small, historic communities like Dawson City carry on their daily routines, completely unaware of the immense tectonic reality that churns deep beneath their foundations. This pristine area, defined by its imposing, rugged mountains and the clear, crystalline ribbons of its rivers, has long harbored a massive geological secret. This secret, dormant for millions upon millions of years, has now been awakened by the meticulous attention of world science. What was once dismissed as nothing more than a peaceful, stable piece of the continent has shockingly revealed itself to be an unprecedented tectonic time bomb, fully loaded and ready to explode. Cutting across this vast, remote region, slicing through dense, near-impenetrable forests and practically uninhabited wilderness, extends an ancient and enormous geological structure. This fracture measures approximately 1,000 kilometers, or 620 miles, in length and is known as the Tintina Fault. This gigantic scar in the Earth's crust is a continental-scale feature. It snakes relentlessly from the heart of the Yukon Territory, across the border, and into Alaska, quietly shaping the landscape throughout immense geological eras. For literally decades, the scientific community had comfortable assurance. They believed this fault was dead. They classified it as inactive for approximately 40 million years, relegating it to the status of a mere relic, a piece of forgotten academic curiosity from Earth's deep past. However, this established narrative is now being utterly demolished. Groundbreaking recent studies conducted collaboratively by the University of Victoria and the University of Alberta are now completely rewriting the seismic hazard maps for the North. What these teams uncovered, deep within the layers of geological data, has radically and forever changed our understanding of the true seismic danger lurking in northern Canada. The key to this revelation was cutting-edge technology. For generations, the dense vegetation and rugged terrain that characterized northern Canada made the region practically invisible to detailed geological analysis. The thick, unforgiving forests and the extreme remote climate made it impossible to observe the subtle, small changes on the terrain's surface, those crucial clues that always indicate past tectonic movement. But everything changed when tools like ultra-high-resolution satellite imagery and specialized LiDAR, light detection and ranging systems, became widely available to researchers. The LiDAR system is particularly revolutionary. It is capable of penetrating right through the dense forest canopy to map the precise topography of the ground below. This technological combination allowed researchers to effectively see through the vegetation, revealing minute terrain details that had been hidden for millennia. What scientists found when analyzing this high-precision data was both surprising and profoundly disturbing. Small ruptures on the surface, almost invisible scars across the vast landscape, began to appear on the topographic maps. These features, known as scarps, resemble subtle, low steps in the landscape, and they are the unmistakable marks left by powerful past seismic displacements. Although they might seem insignificant at first glance, their presence utterly confirms that the Tintina Fault was not completely inactive as previously thought. Each of these subtle marks tells the violent story of an ancient, powerful earthquake, an event that shook the region and left its permanent impression on the crust of the Earth. The data showed that these significant earthquakes occurred in a geologically recent past, specifically between 2,600 years and 132,000 years ago. These numbers may seem distant to us, but in the context of geological time, this is practically yesterday. The discovery, originally published in the authoritative journal Geophysical Research Letters, gained international prominence, immediately alerting the global scientific community to a danger that was being completely and dangerously ignored. Yet the single most alarming aspect of this entire discovery is not just the fact that the Tintina Fault has already produced large earthquakes in the past, but rather what has not occurred in the last 12,000 years. The total, uninterrupted absence of significant seismic activity during this entire lengthy period, which spans the entirety of recorded human history, is absolutely not cause for celebration. On the contrary, it is the most concerning sign of all. While the fault has remained in this prolonged apparent silence, the immense, unrelenting tectonic forces of the Earth have continued to accumulate in its depths. According to scientists' precise estimates, tension has been growing slowly and incrementally at a relentless rate of 0.2 to 0.8 millimeters per year, 0.008 to 0.03 inches, a movement almost entirely imperceptible to any casual observer, but constant and absolutely relentless as the passage of time itself. During these thousands of years of quietude, the fault should have naturally released approximately 6 meters, 19.7 feet, of displacement. But this never happened. All this enormous pent-up energy remains stored there, waiting for the critical moment to be released catastrophically. Experts now warn that when this release finally occurs, and they stress it is no longer a question of if, but definitively when, the result could be an earthquake with a devastating magnitude greater than 7.5 on the Richter scale. To give you an idea of the potential destruction, we are talking about an event comparable in force and energy to the great historical earthquakes that have devastated entire cities around the world. The Tintina Fault has permanently ceased to be a forgotten academic curiosity confined to geology books. It has transformed into a real, immediate, and high-priority threat, a tectonic bomb hidden in the heart of Canada that few even knew existed until now. This crucial reevaluation was only possible thanks to technological advances that have completely revolutionized the way we study the planet's deep mechanics. The discovery of these subtle scars raises a single, frightening question that now keeps geologists awake at night. If such powerful earthquakes occurred in the past, and the fault has remained locked under tension for thousands of years since, why hasn't all this accumulated energy been released yet? Geologist Theron Finlay from the University of Victoria confirms that this groundbreaking discovery was entirely dependent on the expanded availability of high-resolution topographic data, which motivated his team to revisit regions previously, and mistakenly, considered stable and safe. The results are undeniable. The Tintina is not a dead fault, but a living, dynamic, and potentially extremely dangerous structure capable of generating catastrophic seismic events. The recording of small tremors in recent decades, with magnitudes between 3 and 4, may at first seem insignificant. However, these minor tremors do not represent the safe release of the enormous tension accumulated over millennia. On the contrary, they may be signs of growing silent pressure within the fault, much like small cracks that precede the imminent collapse of an overloaded structure. It's as if the Earth is trying desperately to adjust itself, but without being able to discharge the main, catastrophic load that continues to accumulate in the depths of the crust. Each small tremor could potentially be setting the stage for a much larger and more destructive event, something experts genuinely fear could happen at any moment. The very absence of large earthquakes in recent times is, paradoxically, the most reliable harbinger of something much greater and more destructive yet to come. In the critical study of tectonics, prolonged geological silence is often fatally misinterpreted as a sign of stability and safety. But science teaches us the opposite. Long periods of inactivity invariably point to a silent and highly dangerous accumulation of energy that will eventually need to be released. When this inevitable release finally occurs, the energy will be discharged suddenly and violently, causing dramatic ruptures and seismic waves that will propagate for hundreds of miles, affecting areas far beyond the immediate epicenter. The crucial question remains, is northern Canada truly prepared to face this approaching reality? If you found this critical information valuable and want to stay informed about earth-shaking discoveries like this that can impact the future of millions of people, please leave your like and subscribe to the MeteoFoco channel. Activate the notification bell so you don't miss our next videos about geology, natural disasters, and the sheer power of earth sciences. Share this video to spread awareness that can literally help save lives, enduring and prepare vulnerable communities around the world.